Add both 3.2 notes to your table of contents and follow along as we go through these slides. Goal 3.2 reads, I can demonstrate how the law of conservation of matter applies to chemical reactions. So we're going to learn what the law of conservation of matter is, and then I'm going to show you guys how to go about applying this to a given chemical equation for a chemical reaction. So here's what the law of conservation of matter is. You should write this in your notes, so go ahead and pause if you need to. Matter cannot be created or destroyed in chemical reactions. Now, if we think of a chemical equation kind of like a recipe, take, for instance, making a s'more. Here's the recipe for a s'more. You start out with your ingredients. You have your graham cracker, you have your marshmallow, you've got your chocolate bar. You put them together and you make a s'more. So that's very similar to a chemical equation. We start out with certain things and we end up with something different. Here, you'll find at the top of this slide the chemical equation along with pictures of molecules for the baking soda vinegar experiment that you guys performed in the lab. And you'll see that we start off with our vinegar, the acetic acid. We add sodium bicarbonate, that's your baking soda. We end up with three different things, sodium acetate, water, and carbon dioxide. In a chemical equation, instead of calling the things we start out with the ingredients, we call them the reactants. So everything to the left of the arrow, which is your acetic acid and sodium bicarbonate, we would consider reactants. So the substances that you start with in a chemical reaction. What we end up with, we call our products. So in this chemical reaction, we had three products. And those are the substances that you end with. It's like what you make or what you produce in the chemical reaction. So take, for example, the following chemical equation. We have hydrogen gas and oxygen gas, H2 plus O2, makes H2O, or water. If you had to look or analyze this chemical equation, what would you say are the reactants, and what would you say are the products? Go ahead and pause the video and think about it for a second, and then continue when you have an answer in mind. H2, hydrogen gas, and O2, oxygen gas, would be considered your reactants in this particular chemical equation. It's the things that we start out with. And that leaves us with everything on the right side of the arrow, which is just water in this case. Water would be our one product of this reaction. Everything on the left, reactants. Everything on the right, products. All right, so let's go back to this idea of the law of conservation of matter. The law of conservation of matter, which you learned earlier, is that matter can't be created or destroyed in a chemical reaction. But what this actually means to us is that we need the same amount of each element in the reactants and in the products of a chemical equation. In other words, when we go from reactant side to product side, we can't just all of a sudden lose some atoms of an element, and we also can't just end up somehow with more atoms of an element. So there needs to be the same amount on each side. Think of it like this. When you make s'mores, you don't just take random amounts of your ingredients and make a random amount of your product. You need 2 graham crackers, you need 1 marshmallow, and 1 chocolate bar, and that's going to give you 1 s'more. Chemical equations are similar. We need to have amounts of reactants and products. For this reason, you will see numbers sometimes in front of the substances in the chemical reaction. And when you have a number in front of something, that number multiplies all of the atoms that are in that molecule by that number. For instance, let's say that, going back to our hydrogen and oxygen making water equation, let's say that instead of just H2 and O2, that I have 2 H2 and 2 O2. What that would do is multiply each of these molecules by 2. So in H2, normally there's 2 atoms of hydrogen. If I multiply that molecule by 2, then I would end up with 4 atoms of hydrogen. Same thing with O2. If I multiply it by 2, I would end up with 4 atoms of O2. Now, I'm going to show you how to first calculate how many atoms of each element there are. So what you want to do is kind of draw a line down the middle. So wherever this arrow is, We want to draw a line down the middle to separate the reactants from the products. We want to list out each of the elements that we have. So over here we have hydrogen, we have oxygen. Right side we have hydrogen, we have oxygen. And count up currently how many atoms of each element there are. On our reactant side, H2 tells us that there are 2 hydrogens, O2, 2 oxygens. If we go over to the right side, notice that we have 2 hydrogens, but in H2O, there's no number after O, meaning that there's just 1 atom of it and only 1 oxygen. Currently, the way this equation is written, it does not follow the law of conservation of matter because somehow we lost an oxygen along the way. We started with 2 atoms of it, we ended up with 1. That cannot happen in a chemical reaction. So for that reason, like we talked about earlier, you'll see numbers in front of each molecule. In reality, when we react these two things together, okay, we take 2 atoms of hydrogen gas, so 2 H2s, 1 atom of oxygen gas, so we can just leave it as is, and we make or produce 2 atoms of water, 2 H2Os. Now if we count these up, we'll see that we have 4 hydrogens on the left side in our reactants, 2 oxygens. Over on our product side, we now have 2 molecules of H2O. So you've got 4 hydrogens, 2 oxygens. Now, this equation is what we call balanced, and it follows the law of conservation of matter.